Differentiate the following with respect to x. So first thing is we have y is equal to sine of tan inverse of e to the power of minus x. So how many times or how many chain rules do we see over here? Yes, one, the obvious thing is sine. That's correct. Yes, then the next thing is tan inverse of whatever it is. Next thing is e to the power of whatever that is. And in the power there is negative x, so even that has to be differentiated. So there are 4 levels of differentiation. Now we have y prime is equal to cos, right? Differentiation of sine is cos, tan inverse of e to the power of minus x, and we're going to differentiate the next set of expression, that is tan inverse of e to the power of minus x. Next, differentiation of tan inverse of e to the power of, or tan inverse of theta is what? Think of it. Right? It is 1 by 1 plus x square. So we have this to be, I'll write it over here, 1 plus e minus x the whole square. Now, further we need to differentiate e to the power of minus x. So let's move forward. So we have cos of tan inverse of e to the power of minus x. Then we have this dividing or getting divided by 1 plus e to the power of minus 2x. Okay, I've used the exponential formula over here. So it's a bit of extra bit of information. A to the power of n whole to the power of m. It just multiplies a to the power of n into m. Minus will not become plus over here. Reason being, it's in power, right? So think about it. Just don't make it as positive. And differentiation of e to the power of anything is the same thing. But here I need to differentiate minus x as well. So we have this to be cos of tan inverse of e to the power of minus x divided by 1 plus e to the power of minus 2x into e to the power of minus 2x, and when I differentiate this, I'll get minus 1 into differentiation of x, that is 1. Remember, we can remove the constant when we are deriving, right? The formula is somewhere. Okay, not able to find that out. Okay, so it's there somewhere though. You guys have seen this. Limits and derivatives, yeah, it will be over here. In limits, we have seen this. Alpha can get out. So similarly, we have, how come it's missing? Anyways, this we can understand from limits also. Its derivative is nothing but basic idea is from limits itself. So alpha we can take it out. Similarly, I can take out the negative 1, and derivative of x is 1 itself. Derivative of x with respect to x is 1. So finally we can summarize the answer as minus 1 e to the power of minus x cos of tan inverse of e to the power of minus x, entire expression divided with 1 plus e to the power of minus 2x, right? So that would be your final expression. So a extra bit of discussion, again it's from my end, it's not asked in the question. Please don't write this in your exam. It's not required. It's not that it's wrong, it's not required. See, there's no restriction over here, right? So we have tan inverse and all of that. Tan inverse, so it takes up any expression, you know, the derivative of that can take up any expression, any value, not expression, any value. And e to the power of anything is also, it can handle. E can take up any input values. So basically here x can pick up any number. Yeah, so you can pause and have a look.